Now we are going to see two main theorems called first is Cauchy's integral theorem, or we can call it as Cauchy's fundamental theorem. So the theorem states that if f of z is analytic and its derivatives f dash of z is continuous at all points inside and on a simple closed curve C, then integral over C f of z dz is equal to 0. Which means that if you consider a closed curve C, let it be the closed curve C, so inside this curve at all points the function f of z is analytic. Okay, if this condition exists, then we can say that integral over C f of z dz is equal to 0. Okay, that is what this theorem states. That is here, which is given that f of z is analytic at all points inside and on the simple closed curve C. That is the meaning. That is, f of z should be analytic at all points inside the closed curve C, means then integral f of z dz is equal to 0. Right? The next theorem, what it states, Cauchy name of the theorem is Cauchy integral formula or Cauchy fundamental formula. It states that if f of z is analytic inside and on a simple closed curve C that encloses a simple connected region R, and if A is any point in R, that is, same way here you consider a simple closed curve C. Inside it, at all points inside and on simple closed curve C, it is analytic, and there is one region R which is enclosed by a point A. This is what it is given. Okay, A is a point inside the region R. Okay, then what do you mean by f of A? If you want to find out f of A at this point, then f of A is defined as 1 by 2 pi I integral over C f of z divided by z minus A into dz. Actually, this gives you the value of f of A here. Actually, in other words, what is meant by the point A means, otherwise this point A is called as singular point. Why it is called a singular point means, at this particular point the function won't be analytic. Okay, so whenever there is a point where the function is not analytic at that particular point and that point is inside the closed curve C, then we have to apply this particular theorem, that is Cauchy integral formula or Cauchy's fundamental formula we have to apply, where C is described in the anticlockwise direction. Based on the above theorem, we have to see one corollary, that is, if a function f of z is analytic within and on a simple closed curve C and A is any point lying inside the curve C, then fn of A, in the previous theorem we saw that f of A, here it is fn of A, which means that n stands for the nth order derivative of the function f. So fn of A is defined as n factorial by 2 pi I integral over C f of z by z minus A whole to the power n plus 1 dz. Actually, this statement can also be written like this by taking this n factorial by 2 pi I to the left hand side. If you take it like this, then it gives you the evaluation of the integral f of z by z minus A whole to the power n plus 1 dz. So that will become the left hand side here, which is equal to, the right hand side will be 2 pi I divided by n factorial into fn of A. Right. So here, if you notice here, if you want to evaluate any particular function where A is the singular point inside the curve C, means we can apply this corollary, or we can apply the previous theorem also. Right. Let us see the definition of a singular point. A point z equal to z naught at which a function f of z fails to be analytic is called the singular point. Already I told you that singular point means the point where the function is not analytic. So this is an example for singular point for a function for which the function is not analytic. F of z is equal to 1 by z minus 3. Here z equal to 3 is called as singular point. To find the singular point, we have to equate the denominator to 0. So denominator to 0. Here the denominator is z minus 3. So if you equate z minus 3 is equal to 0, so z equal to 3. So we can conclude that z equal to 3 is the singular point. Likewise, if there are more than one or two terms in the denominator, equate it so that all those points are called as singular points. So a function may have more than one or two singular points. Okay, this is an example. It is given for which only there is only one singular point z equal to 3. There may be some more functions where the number of singular points may be more than one.